Good morning all. So today we'll be studying a session on assembly language program in your ARM and embedded system. In this session we'll be elaborating about high level language based developments. So what is this high level language based development? First and foremost, embedded system software. So when it comes to embedded system software, in the early days a embedded system software was written exclusively in the assembly language for the target processor. This is because this gives the programmer a complete control of the processor and other hardware. The hardware was very small, but the user was able to write the assembly language, which was better for the hardware to understand, but at a price. This was the earlier days. But coming to assembly language, there are many disadvantages, as we have seen, compared to your high level software development. But the cost and the lack of code portability will come into picture. In addition to this, finding skilled assembly program has become much more difficult in recent years. The reason here is the assembly language program, writing the assembly language program is very difficult, and a skilled person getting nowadays is very difficult for the companies. This is one disadvantage in assembly language program in the recent years. Assembly is now used primarily as an adjunct or addition to the high level languages. That's what we are going to see here. That was a disadvantage with your assembly language programs. So coming to your assembly adjunct or addition to high level language, why do you want to add this to the system? Why do you want to add assembly language with your high level languages? If you see, assembly is now used primarily as an adjunct or addition to high level language, usually only for startup or system code, or startup system code we can call it as. Those small pieces of codes that can be extremely efficient or ultra compact. This we have observed in many of the systems, like your phones, smartphones, or your flash drives, or your laptops with your BIOS inputs. Those are all work on your assembly languages, which is nothing but a small piece of codes that are very extremely and efficient in sort of booting or running the system. So that's about your assembly language. So when we come to C language, the C language has become the language of embedded programmers. The reason is understanding the C language is better than understanding the assembly language. Assembly language is a little bit difficult compared to your C language. C language is user friendly, so it is very easy for the user to understand. C is the closest thing where it is a standard in the embedded world, where everyone tries to use the C language. As we know, the C programmer, he can have plenty of advantages by using this C programming language. It can be a small or family a little bit bigger, or it can have a compiler which are already available in the market for every processor in today's world. So if it is easily available, firmware for a processor is available, then it will be very easy for the user to run the code or write the program in C language. That is the advantage of your C. So this is the main advantage of your C over your assembly program. And we have seen a large part of experiments which are going on in today's market is based on your C programming and by the programmers. And we also observed that there is one more called as C++. It's nothing but your object oriented program. and it has become an increasingly popular among embedded programmers. It's a part of C, but sometimes we use C, sometimes we use C++. Now the advantage of C++ is you have some new added features that is better than your C, and there are some limitations when it comes to C++ and C for the style of the programs. And most of all the core languages features they add on with your C as well as C++. And if you observe, there are few features are very useful to the software developers which are available in the market, as we call it as Flash, but some of them reduce the efficiency of the executable programs. So this is with respect to your time. So time is very important here. That is nothing but your processing time. So that is the reason C++ tends to be most popular with large development teams. If you observe, I'm speaking about large developments. When it comes to small scale or small development, most of them concentrate on C rather going for C++. So that is about C++ with respect to C and its advantages. So why we people go for C and why we study more about C languages than C++. C is more related to a small scale or what we call it as small units programming, but C++ will be used for large scale where it can be handled by large development teams. That is the difference and advantage with respect to C and C++. The last thing in this concepts what we are studying in high level languages are ADA. I think we have all heard of ADA. It's also an object oriented language, but the slight difference from C++. It was first originally designed by US Department of Defense for the development of mission critical military softwares. So if I say about ADA means, if I speak about ADA means, it was first developed for the US Department for the Defense. Okay. Despite of using these softwares, most often used is C. The very good reason for this is we are getting fairly better firmwares which are easily available for the processor. That is one advantage, where the user or the C programmer can use it for further implementations. So most of small scale developers use C rather using C++. Okay, coming to mixing assembly and high level languages. Why do you want to mix is one question. So in sometimes advantages of calling a subroutine written in assembly language from a program written in C, or we can call a C program vice versa with the assembly. So subrouting is something like a small programs which are written and it's called more than once, then we call it as a subroutine. Let us take an example here. If I write a small code, let us say I have a keypad here. It's a 3x4 keypad which is connected to my microcontroller. I'm just writing 3 lines, but there is not 3 lines, there is more than 3 lines. Okay, it's connected. This is your keypad which is connected to your microcontroller. What exactly we are doing here? We are giving some inputs to your microcontroller, which is an input device. So there is one thing, for every input there is a processing and there is also an output. Here we call it as LCD. So what is this assembly and what is subroutines? If I write a C code, inside that I can call a subroutine. This subroute can be in assembly. This can be in assembly. What is this assembly code here? We call it as scanning. What's called as scanning. What I am doing here, what I am scanning here, I am scanning row wise as well as column wise. Row wise and column wise. Column wise, row wise. What exactly we are doing? We are identifying which is the number has been pressed by the user. It can be 1, it can be 2, it can be 3, it can be 4, it can be 5, so on. If I am going to press 2, so which is this column? This is column 2. Which is the row it is? It's row 1. So if I say row 1 column 2, the input given by the keypad is the character or the number is 2. The 2 is given to your microcontroller. Now microcontroller will verify it and it will be sent to your LCD, and 2 will be displayed on LCD. So this is nothing but I am going to scan and do this job. The job is something like scanning row, scanning column, scanning row, scanning column. The only thing is the number of rows will differ, the number of columns will differ. The next time it can be of row 2 column 1 or row 2 column 2 or row 2 column 3. So this can be written in a small subroutine code rather writing in a main code. So this is one advantage of your mixing your assembly language with your high level languages. So if I do this by running a subroutine, my code will reduce, the code size will be reduced. If the code size is reduced, the speed of the system will increase. That is one main advantage of nowadays the programmer are seeking to. Okay. Many programmers are more comfortable writing in C, and for one good reason, that is in a middle level languages the programmers can have some detailed information of actual implementations. That nothing but your C is a middle level language, we all know that, but when it comes to assembly language it will have a better implementation where the user can have better input output or handling the information or handling the editable options for the input to your output. That cannot be done much in your C compilers, but that can be done in your assembly languages. So that we can call it as some low level tasks that either can be better implemented in assembly languages. Low level task, okay, let us see that how the low level task comes into picture. So what is a low level task here? So when I say about low level task, let me call here is my PC. I am connecting one printer. This printer is given to the PC. I am giving both the ways. Actually printer is a output device, but there is data as well as control signals. So control signals can be bidirectional, data can be of one direction. So control signals can also be called as a data which is flowing from printer to PC. So this is your PC. Now coming to your where do we use this assembly language? That is the question. So most of your higher level languages are written in C as well as C++. Coming to your low level languages, what is this? This is a printer. So a printer needs to run at low level. That's called nothing but assembly language. Why we use assembly languages in printers? Because it is having a hardware unit, very small hardware unit, and as a processing unit. It has a processing unit and a small hardware unit. That's we call it as device drivers. Device drivers. which will drive this hardware by using this software. These device drivers are written in high level languages for PC, but communicating bit with your printers, they are written in assembly language. So there is an interaction between your high level and low level languages. So what happens in printer? When I give a input, when I give a print from your PC, that is sent to your printer. So that are converted into low level languages and finally zeros and ones. So that information is fed to the small hardware, which is nothing but a small processor which is present in a printer. From this printer, the information is sent to the device, secondary device, and that starts printing the information. So at that point we use assembly languages because it is faster compared to your higher level language or mid level languages. So that is the advantages of your using assembly over C. So that was the advantage. So assembly languages are also used in some critical situations or real-time processors, unlike your high-level languages. The reason is timing. The timing can be strictly controlled by using your assembly language codes. The reason is assembly language codes are much more faster compared to your mid-level language or higher level languages. They run very fast because the execution speed is high. But writing in assembly language is difficult. Getting the people for writing assembly languages is very difficult nowadays. But people who are writing in C languages are easily available. But the disadvantage in C or high level languages is time constraints. They are not much faster. So in most of the real-time systems, they use assembly languages, which are directly communicated to the hardware. That is the advantages of your assembly language. Okay, coming to your C language versus embedded C and its advantages. So what is C language? What is the difference between your embedded C and its advantages? As we can see here, embedded C, it's an extension of a C program language. It's nothing but an extension of your C program language. Your embedded C includes a number of features which are not available in normal C. You don't know, I think you people don't know about it, but there are a lot of features. What's that? What are those features? It has a fixed point arithmetic and some named address space, and also few basic I/O hardware addressing, which are not available in normal C, because normal C will not be working much more at low level like your small scale hardwares. Usually use C and C++ for higher level and mid level. So there comes your embedded C. So C is generally used for desktop computers. As we all know, we all use desktop computers, or it can be of laptops, any other gadgets. We generally use C language. But when it comes to embedded C, it is used for microcontrollers and its applications. And everyone know that, very well known, that C will be used in most of your microcontrollers. As we have observed in your labs, we use C language. Okay, next, embedded systems have some limitations. What are those limitations? We all know with respect to memory. So when I speak about memory, memory is nothing but your ROM and RAM. ROM and RAM. And when I speak about ROM and RAM, your main data or the code what you are going to write will be stored in ROM. The input output what you are going to give to the system is temporarily stored in your RAM. So if you see here, most of your smartphones, if you want the more number of apps to be installed, we always refer how much RAM we are having in the system. That means which gives more the RAM, more the speed, more the faster the system will work. That is about your RAM. ROM is a temporary location, or we can say permanent location, where you are going to store the data where it should not be erased. There is no power. So there comes your main codes. And the most embedded systems have limited ROM, RAM, and also it uses less processing power, as we see. So one should take care of limiting resources while writing the program in embedded C. So if I write a very big program into a ROM, the memory capacity of ROM is limited. If you cross that limitations, means you can't run the system at limited power. That is one disadvantage in your embedded system that has to be taken care by the developer. But when it comes to C language, like your what do you say, desktop computing, when it comes to desktop computing, the C language desktop computing has access to system OS, where you can have a big memory in it. That's nothing but your hard disk, which has more space for the user to write the information. So when it comes to embedded C, which includes extra features such as fixed point type, multiple memory areas, and I/O register mappings. So they are being used in many of the features for running in a small units. In the same way, C compilers typically has like OS dependent files. All of you know that .exe extensions for Windows, and as well as compilers for embedded C, creating file .hex. This you think all know. So when I come to C languages in your PC, we all know that an application is executed by .exe execution file with an extension. When it comes to embedded C, debug the code, and the final part of it is .hex, hexadecimal value or hexadecimal data, which has been executed. It will be executed by the hardware, which is dumped into the hardware. That is nothing but you are using the extensions to dump the code into the microcontroller microprocessors, or we call it as code burners. Code burner, which is used to dump the hex file from your system to your hardware. That's what you are going to do in your labs. So that is one advantage of your embedded C versus your C compilers. Coming to your applications of embedded C here, where we use these applications. The applications are written in embedded C starts when the system starts. Try to understand this. Then if you write a code written in embedded C, starts when the system starts. When you reset the system, let's say it starts from the starting address and never end until the system stops. It's a continuous loop. That is the reason we use while of 1. While of 1, it's an infinite loop. So the code which I am writing inside this will be running in infinite times until you are going to stop it. There is no user to run the applications. I don't need any user to initiate it, start now, stop now. No user is needed for the application to be started. It will be done, it will be running by itself until it finishes its job, which is controlled by the user while writing the code. So where do we use this embedded system? Embedded systems applications. Embedded C is used for microcontrollers like TV, washing machines, daily usage, where C finds applications in a logical programming, OS based software, etc. I think you are understood with this. Application of embedded system is washing machine and your smart TVs and many more, refrigerators, smart refrigerators nowadays. And your C will be used as an applications of your OS, types of OS, development of OS based softwares, comes under your C. The C can directly run from OS terminal, whereas embedded C need to be created the file first. We all know C can be run. Say I have OS. Onto the OS I can run a particular program. It can be a PDF reader, it can be a Word reader, or it can be some other softwares which are written on your C, but it is running on OS. But it's not like in your embedded C. Embedded C we can't run like this. In embedded C we need to create the file first, then you have to download that to the embedded system where a compiler processor is carried out. So when you write a code into a system, when your PC, that you need to dump it into hardware, you can't do it directly. What you have to do, you have to compile it, then put that code into the hardware. That's what we are going to do in your embedded C. So after compilation you are going to load, but in C it is different. So that is the difference between your embedded C and your normal C. And one more very important thing is no data can be input in embedded C while running. So I am running a hardware here. I cannot put a input here into the code directly. If I want to change something, means I need to change the code, the data here first, then I need to compile it, then I need to load it here in embedded C. While coming to your C can easily take inputs or a program data while it's running. So that can be of different type, where you can give an inputs to it and it will take and it will run. So that is the applications of your C over your embedded C. That is the main difference between where your embedded C will be used and where your normal C will be used. Very important concepts. Okay. Next is compiler versus cross compilers. So what is a compiler? Compiler is nothing but a software tool that converts a source code written in high level language on top of the particular OS running on a specific target processor architecture, and it is also called as a native compiler. So what is a compiler? It is a software tool that converts a source code written in high level language on top of a particular OS. Try to understand this. It is a software tool that converts a source code. I have source code here. I have a source code here. Written on which language? High level language. High level language means it is nothing but C language on top of a particular OS. So on what? On top of a OS. So this is my OS. There comes my high level language code. Onto a target processor, I want to dump this onto a target processor. Here is my processor. It has some architecture, so that processor architecture I am designing it and loading that into my system. This is called native compiler. Very, very important. Try to understand. The compiler is also called as a native compiler. So always a compiler is nothing but a software tool that converts a source code which is written in high level language on top of a particular OS. When it comes to high level language, it is nothing but C language for a particular architecture. That is also called as a native compiler. Okay. What is a cross compiler? A cross compiler is a compiler which runs on one machine, that is called host machine. So here is one machine, here is one more machine. So cross compiler is a compiler which runs on one machine. Let me call it as machine 1 and let me call it as machine 2. So this is called a host machine and this is called as a target machine. So I have two machines here. I am running one code on a host machine, but emits code for what? Another machine. Emits code for another machine. Which is that machine here? That is M2. That is nothing but your target machine. So that is sent to your target machine. Try to understand. A cross compiler is necessary to compile for multiple platforms from one machine to another. So this is your host machine, this is your target machine. So if I can have more number of target machines here, I can do that, I can dump it into the target machines. So there we use yes cross compilers. So cross compiler applications also provides lot of informations. Cross compilers applications also provide all the features that native application provides and performs, and what you call it as performance, which is not affected to the system. Cross compilers are mostly used in when it comes to host machine and target machine. And when it comes to native compilers, it generates a machine code for the same machine on which it is running. The difference between these two is this runs on different machine, this runs on same machine. It compiles on the same machine. Native compilers are also called as compilers. Cross compilers will compile from one machine to another machine, that is host to target. It can be of many targets, that is called cross compilers. A compiler where target is in the same system is called native compilers. Cross compilers, a compiler where target is not on the same host. It is not on the same host, it is not on the same device, that is called cross compilers. So that is the difference between your compiler, cross compiler and native compilers. So by then you will understand that what is compiler, what is cross compiler, what is native compiler. Native compilers are also called as compilers. So these compilers where the same system compiles in the same domain or same hardware, it's called native compilers. So one host to the next target, if I am compiling it, is a cross compilers. Hope you all have understood of today's session. So any queries, you can send me questions on WhatsApp. Thank you all.